Hello students, so we are going to solve this question. Question says that the stationary body acted by a number of forces. State the two conditions which must apply for the force to remain at rest. So first part of the question here. So as you can see here, we can write here when the resultant force is equals to 0. That time it will be at rest. Resultant force is equals to 0. Or second, we can write here no resultant moment or no turning effect. When there will be no turning effect, that time also the body will be at the rest. So we can write no resultant force. That same thing here. What resultant force equal to 0. So it is also same thing. So we can write here no, or no turning effect. No turning effect will be there. Now B part of the question we are going to solve. This is a mathematical question. So figure 3.1 shows a device used for compressing crushed material. So here they have given this length, here 20 Newton. So we will read the question. The lever arm rotates about the hinge at hinge H at the right hand end. A force of 20 Newton acts downward on the left hand side of the lever arm. The force F of the crushed material on the plunger acts upward. Ignore the weight of the lever arm. So we will solve this question here. Okay. So as you can see here, this is the question. So first part of the question. Use the clockwise and anti-clockwise moment about H to calculate the upward force F which the crushed material exert on the plunger. The distance are shown in figure 3.1. So we are going to solve this question. So as you can see here, anti-clockwise force. So anti-clockwise force, here we will make a clock. Like here this is the clock. So anti-clockwise means this side it will move. So anti-clockwise, this is anti-clockwise. So this is anti-clockwise. And clockwise force. So it is coming down. So you can see this one is acting like a anti-clockwise. How the clock needle moves, it's opposite to that. Now here clockwise force, we will make a clock here. And this upward force, you can see upward force is there now. This upward force is acting like a, here you can see it's like clock, how the needle of the clock moves. So here it is clockwise force. Here low CK, this one wise force, which is upward force. Upward force. So and this is downward force. Downward force. So we will going to solve this. So as you can see, anti-clockwise force is equals to clockwise moment, anti-clockwise moment equals to clockwise moment. So we will find out all. First we will find out clockwise moment and then anti-clockwise moment. So you can see clockwise moment, as you know, here this side where F is written, this was the clockwise moment. So clockwise moment. So for this we can write here clockwise moment. Clockwise moment equals to, so here we don't know the value, so we can write here force into, so perpendicular distance we can see here it's written 120 mm, so we have to convert it into centimeter. So it will be 120 by 10, so it will become 12 centimeter. So here it is 12 centimeter. So clockwise moment we got. Now we will find out anti-clockwise moment. This side is anti-clockwise moment. So anti-clockwise moment this side. So now for this we want to find out. So anti-clockwise moment equals to, so same force into perpendicular distance in centimeter. So force. So let's find out the force. So you can see here the force is 20 Newton. So we will write here 20 Newton into the perpendicular distance. So perpendicular distance means 380 mm plus 120 mm, because whole of the force it is acting here. So from this also combined. So both we have to combine here. So we will add both the force and we have to convert it into centimeter first. So 380 divided by 10 will become 38 centimeter plus 120 divided by 10 will become 12 centimeter. So this whole thing will become 50 centimeter. So for anti-clockwise the distance, perpendicular distance is how much? 50 centimeter. So perpendicular distance is 50 centimeter. 50 centimeter. So we have applied here 50 centimeter. So let's solve this here. So if 2 5 is 10, so it will become 1000 Newton centimeter. So now, as you know, clockwise moment equals to anti-clockwise moment. So we can apply here. So clockwise moment equals to anti-clockwise moment. So we can write here clockwise moment. I will write clockwise moment equals to anti-clockwise moment, ACW. I will write like this short form. So clockwise moment is force into 12. So this one, F into 12 is equals to anti-clockwise moment. As you know, this 1000. So here we can write here force equals to 1000 divided by 12. 1000 divided by 12. So we will be getting this as 83.33 Newton. 83.33 Newton. So 83.33 Newton, we got the answer for this. So we will write here answer is 83.33 Newton. Now they have asked this second part of the question, what they have asked. So the cross sectional area A on the plunger in contact with the crushed material is 0.0036 meters square. Calculate the pressure exerted on the crushed material by the plunger. So pressure. So we have to apply the pressure formula. So pressure equals to force upon area, cross sectional area. So here, as you can see, force we got here 83.33 and cross sectional area. So cross sectional area we have to check how much it is there. So let's see cross sectional area. Cross sectional area here, let's read in the question. So cross sectional area is equals to, so cross sectional area we can see in this question here, it's given here. So 0.0036 meters square. 0.0036 meters square. So let's solve this. We are going to get 23,138.889 Newton per meter square. So we got this answer. So don't forget to subscribe my channel. Thanks for watching.